Many rovers in the past have been performing tasks such as taking pictures and examining samples at Mars, but many solar-powered rovers have limited or non-existent nocturnal operations, like the Sojourner from NASA, and they're known to not be able to turn or tilt its solar panel. However, rovers in the past pointed towards the equator, the median position to charge, but it was just a heuristic solution to efficient solar charging. This project aims to test a new solution, which is programming a mock rover to turn towards the sun as the sun's position changes relative to Mars. So the overall goal here is to prove that continuous direct exposure to the sun can increase battery life and allow for enhanced nocturnal operations if it's implemented on real rovers. Efficiency will be measured by observing the impact of the program feature on the battery capacity at the end of testing. So this is the construction step where it was modeled in computer-aided design and then 3D printed, and the electronics were connected with the Arduino Nano and a portable charger power source. And this is what the completed rover looked like with the solar panel and servos. So this is the program I created to perform the task without the feature. So this was written in Arduino, which is very similar to C programming, which is what I learned at CS50. So first, the header is declared to include the servo library, along with the variables I used throughout the program and the functions I made for better readability. And void setup only runs once at the beginning when the rover was plugged into the power source. And void loop runs over and over again, which is where I wrote the task to go back and forth. So this is the program I wrote with the feature. And so in addition to the task that I wrote previously, the red highlighted stuff was what I added to the loop function. So first, it gathered the light from the analog pin with the phototransistor, and that value would be scanned for if it was ready to scan in a for loop, and the highest value would be recorded, and then it would turn to that highest light value, and then it would start monitoring after it's turning. And let's say that the value changed significantly, so by 40 analog values, it would set scan to true and it would start scanning again, and simultaneously the task is occurring. So this is Add Meliora in action, and you'll see that it stops exactly where it finds the highest light source. So for testing, the rover was run from sunrise to sunset, and in both instances, the rover was initially placed facing north, which was a median position. But the rover with the feature was able to turn itself to the brightest light direction. The current in ampere was recorded each hour, as you can see, and on average, the amps with the feature was higher. And as you can see in the graph, the variability in the amps over time is less with the feature. So the battery capacity at the end of testing can be measured in milliampere hours. Without the feature, it was calculated to be 2,300 milliamp hours, and with the feature, using the average amps, it was calculated to 3,400 milliamp hours. So the percent change is 47.83%, so approximately a 48% higher battery capacity by implementing the autonomous feature. And so this proves that solar energy can be made more efficient and can be used in smaller missions and could substantially reduce costs in the future for future Mars rovers exploration.